uh, I will discuss today chemical bonding. Okay, so in your syllabus, chemical bonding containing the topics are covalent bonding, VB theory, that is valence bond theory, VSEPR theory, MO theory, homonuclear and heteronuclear atomic molecules and bond order, magnetic properties, resonance, hydrogen bonding and van der Waals force, ionic solid, bond Haber cycle, Fajans rule. Okay, so these are the topics. Okay, so this is a very vast syllabus. Okay, for from this topic every exam have asked questions. Okay, so in lecture 1 I will just discuss on the VB theory and covalent bonding. Okay, so first that is a chemical bonding. What is chemical bonding? Basically it is a force of attraction between two atoms to form a stable compound. Okay, why this stable molecule is formed? Because due to the form of chemical bonding, potential energy decreases, so stability increases, and every molecule have a tendency to attain nearest noble gas electronic configuration. Okay, next chemical bonding is three types, that is ionic bonding, covalent bonding and coordination bonding. Okay, so basically the part is that covalent bonding. Okay, so what is covalent bonding? At first we have to know it is formed by mutual sharing of electron, that is valence electron, okay, between two atoms having same or nearly same electronegativity. This is two types basically, non-polar covalent bond and polar covalent bond. Okay, for non-polar covalent bond, that is example you have if you know that H2O2 into Cl2. Okay, if you take this example, I will conclude that same electronegative element, that is non-polar covalent compound, is mainly formed and it is mainly a non-metal. Okay, next polar covalent compound, that is different electronegative element form polar covalent compound, and if an example that is HCl. Okay, next we have to know the characteristics of covalent compound. Okay, so basically there are many characteristics, but the important characteristics are mainly physical state. Okay, so these compounds mainly are gas or liquid, but exception is there, that is diamond, SiO2, that is silica, carbon and silicon carbide, aluminum nitride. Okay, you have an homework that what is carbon. Okay, the formula of carbon. Okay, you give in the comment section. Next conductivity. Okay, not conductor of electricity, they are all covalent compounds, but except graphite, because graphite, if asks question that why graphite is conduct electricity, that is in graphite that is a sheet like structure or layer like structure. One carbon atom is attached to three carbon atom. Okay, and so the valency of carbon, I know you know that that is 4, so one electron is unpaired here. Okay, one electron is or one electron is unpaired here. This electron is basically the reason for the conductance. Okay, so next solubility, we know that covalent compounds are, that is non-polar. Okay, so basically they are dissolved in non-polar solvent like CCl4, that is carbon tetrachloride, CS2 carbon disulfide or benzene. Okay, next VBT theory. VBT theory is given by Hitler and London. Okay, it extended by Pauling and Slater. Next postulates. At first a covalent bond is formed by overlapping of half-filled valence shell electron or valence orbital. Okay, what is the meaning of this? Because if you take an example F2, that is fluorine, F2 molecule, two fluorine atoms are bonded to each other. So one fluorine have an 9 electron. Okay, so if we draw the electronic configuration, that is 1:2h2, 2p5, 2h2, 2 electron are 2 in the 2s orbital, and 2p for 2p there are 5 electron. Okay, next fluorine atom also the electronic configuration same. So here one unpaired electron is there, here one unpaired electron is there. These two unpaired electron can form an overlapping. Okay, so basically the orbital structure 2p, that is this type of structure are here, and 2p overlapping is formed. Okay, next, pairing of orbital takes place in such a direction so that maximum overlap can be possible. So covalent bond is directional. It is very important postulate, and so basically the covalent compounds are very stable because of extent of overlapping. Okay, bond strength, that is bond strength is proportional to extent of overlapping. Okay, next, extent of overlapping depends on two factors. First one is nature of orbital, that is for p, d and f they are directional, so maximum overlapping here, and s orbital, that is non-directional, that is minimum overlapping are there. Okay, if you can, why this is directional and this is non-directional, because if you draw the s orbital, that is it is an circle shape. Okay, okay, next if you draw that is p orbital, that is px, if you take this is x axis, this is x axis, if you take so basically this is px, if you take this y axis, then this is py, or if you take this is an z axis. Okay, these three are perpendicular in this direction. So if you write in one case, then this is okay, this is px, this is py, and this is pz, py, yes. Okay. So these are basically directional. Okay, so for directional orbitals maximum overlapping are there, and for non-directional orbital minimum overlapping are there. Okay, next, nature of overlapping. Two types of overlapping are there. One is coaxial overlapping, that is more overlapping, that is in axis wise overlapping are there, and collateral overlapping, that is in perpendicular to the axis. Okay, so less overlapping are there. First one is coaxial overlapping. What is this? This is the type of overlapping, end to end overlapping or axis wise overlapping. Okay, takes place resulting in form of sigma bond, that is sigma bond. Okay, if axis wise overlapping or end to end overlapping are there, this is sigma bond. At first, s overlapping. What is s overlapping? That is two s orbital are there, that is two structure of s orbital, these are overlap between to each other and sigma bond is formed. If you give an example, that is hydrogen, atomic number of hydrogen is 1, so there are one electron, two electrons are there in the s one is orbital. So these are basically, if we overlap this to each other, then H2 molecule is formed, and this is the directional. Okay, next, sp overlapping, that is s orbital and p overlapping. Sp overlapping, if we given that this is a sigma bond is formed, if we take an example, that is hydrogen and fluorine. For hydrogen, one s orbital, one electron, and fluorine 2s and 2p. There are one electron in 2p orbital, so 1s and 2p is overlapped and HF molecule is formed. Okay, next, pp overlapping, that is basically two p orbitals are overlapped between to each other. If we take this is px or py or pz, then px form or py form or pz formed. Okay, so basically this is an also an sigma bonding is formed. Okay, so three types of overlapping are there: ss, sp and pp. These are sigma bond is formed. Okay, and if we take an example, that is fluorine, that F2 molecules, 2p overlapping are there. If we take Cl2 molecule, then chlorine, that is 3p overlapping are there. Okay, next, collateral overlapping. Basically this is the type of overlapping takes place perpendicular to the internuclear axis. Okay, perpendicular, and resulting in the form of pi bond. So if we takes place the perpendicular overlapping of nuclear axis, that is pi bond, and if we take end to end or axis wise overlapping, that is sigma bond. Okay, so basically these are two p orbitals. Okay, this type of, if this type of overlapping are there, so this is pi bond. Okay, so strengths are sigma bond and pi bond. Strengths are, that is first coaxial, from coaxial one pp overlapping is greater than sp, then ss, then collateral, that is pi bond, pp overlapping. Okay, so if we take an example O2 molecule, okay, for O2 molecule atomic number is 8, so 1:2:2 and 2p4, two unpaired electrons are there. So basically if we take two oxygen atom for O2 molecule, one sigma bond is formed, one pi bond is formed. Okay, so sigma bond is formed basically if we take that is px, so px overlapping sigma bond is formed, and py overlapping is pi bond is formed. Okay, next N2 molecule, for N2 molecule, that is there is one sigma bond and two pi bond. You can draw the structure. Okay, next if we from this topic overall I have concluded basically 3 notes are there. Okay, if in the exam basically these are, if you have to remember for question solving, that is bond strength is proportional to extent of overlapping. Okay, first one pp overlapping is greater than sp, then ss. These three are coaxial overlapping. Okay, that is sigma bond is formed by this. Next pp overlapping, that is pi bond is formed, that is collateral bonding. Okay, next bond strength is inversely proportional to size of the orbital. If n is increases, bond strength decreases, that is n is the principal quantum number. Okay, so 1 1, then 1 2, then 2 2, then 3 2, then 3 3. Okay, if n is same, that is principal quantum number, if same, then 1s is greater than 3p 3p, then 3s 3p, then 3s 3s. Okay, next bond strength of pi bond, that is first one is 2p overlapping is greater than 2p 3d pi. Okay, next 2p pi, 3p pi, and 3p pi 3p pi. These are very important concept you have to remember for question solving from this examination. Okay, thank you.